Hi, I'm Nithya Sambasivan. I'm a researcher at Google Research, and my talk today is about myths and misconceptions around data when transposed to the global south in research of and by the West. I want to problematize implicit and explicit norms within fairness that they work regardless of social, political, ecological, or infrastructural contexts. I center my talk on data, the most crucial technical infrastructure for fairness, and more broadly, AI and machine learning. In addition to fairness, data can also determine performance, scalability, robustness, and safety of AI systems. An assumption is that data is objective, unchanging, and accurate enough to be used for training or evaluation of inferential technologies. Let's look at how these play out in the global south, where data often gets challenged, but also offers fruitful alternative realities and solutions that need to be considered. AI and ML technologies are widely accessible and democratic around the world thanks to open sourced and pre trained models, easy to access courses, and praxis communities. But it is with data and compute where we start to see disparities globally. With limited digital infrastructures, ready made data sets are often unavailable in the global south, and this necessitates ML researchers and practitioners to go out and collect their own data, which is something that AI education does not prepare one for. The state and industry apparatus collect and retain valuable large scale data in the global south, but data sets may not always be made publicly available. In India, for example, data sets featuring migration, incarceration, unemployment, and education divided by subgroups, which are so valuable for ML fairness research, are regularly unavailable to the public domain. And the context here is that AI is often optimistic and aspirational in many contexts of the global south, often rooted in hype and promise. And AI solutions may have end-to-end opacity in a context like India, where there is opacity on problem statement, data set, and model outputs, in contrast to the widely discussed model explainability issue. And AI solutions may often be readily adopted, often too early. Data is representative. Social contracts and infrastructures in India can challenge the assumption that data sets are faithful representations of people or phenomena. There is an assumption that fixing the data will fix the bias. But data can often be missing in the form of digital divide, where 50% of the country does not have access to the internet, and this excluded half is primarily made up of women, rural communities, and Adivasis, who are the indigenous tribes. As a result, any digital data is a representation of the privileged. Data can also be missing due to artful and creative user practices to manipulate algorithms, which may arise from needs of privacy, counter abuse, and reputation. Data is valued. Despite the importance of data in AI and machine learning, data is the most undervalued and deglamorized aspect in the AI community, especially vis-a-vis the lionization of model development. So in an upcoming paper at CHI, we talk about data cascades, which we observed with the AI, ML practitioners and researchers from around the world. Now, we define cascades as compounding events causing negative downstream effects from data issues. These are widely prevalent. 92% of the practitioners we interviewed reported facing at least one data cascade. And they can be rather serious. They're opaque and harmful to communities in the downstream. Data cascades stem from practices that are derived from conventional machine learning, which come from worlds of big data like ads technology, a lack of practical data ethics, and serious flaws in AI and ML incentives and education. We find that many practitioners reported to hack models for accuracy rather than for quality, safety, or process. Data is technical. A rich human infrastructure from India's public service delivery, like frontline workers, extends into AI data collection. Now, while frontline workers often have pride and prestige in doing good work, data collection is orthogonal to their goals. It's often a barrier, and it can introduce new workflows and processes that are in conflict with their goals, which may be, for example, to provide care to patients. In this quote, a practitioner says, often they, the frontline worker, forgot to reset the setting on the GPS app and instead recorded every 5 minutes instead of recording every 1 hour. It is useless. It messes up my whole ML algorithm. We observe that there are misaligned incentives between frontline workers and disproportionately so for ML developers. There's poor data literacy and there's opacity around the downstream users for which they're collecting the data. And consent to a data worker can come from high interpersonal trust and from holding them in high respect. These are not relationships that are transitive to downstream AI applications. Data is uniformly distributed. Now, proxies in the global south may be similar to the West, but may have different implementation nuances. For example, in India, a name is the most semantically meaningful proxy. It can communicate caste, gender, religion, class, ethnicity. Zip codes are rather heterogeneous, with slum communities abutting posh housing, which may be somewhat different from contexts where there were segregated paths of redlining. Mobility is inversely proportional to gender, where women report safety concerns and hence have lower mobility, and persons with disabilities also have lower mobility due to limited infrastructure like ramps. Occupations, especially the traditional ones, may correspond to class and caste and religion locations. Proxies may not even generalize within a country. Like in India, asset ownership means something entirely different in a metropolis like Mumbai versus a small town versus a village. Importantly, AI systems in India remain under-analyzed for biases, mirroring the limited public discourse on oppression, say in contrast to the anti-racism discourse. There's also other axes of discrimination to consider, which may be very specific to any local context. In the context of India, for example, we bring up caste, religion, gender identity, and more, which could be a starting point for fairness tests. Data is uniquely identifiable. Now, statistically, fairness makes a critical assumption so pervasively that it is rarely even stated that user data corresponds reliably to a unique individual in the real world. This often gets challenged in the global south through shared device ownership and usage, and the use of multiple SIM cards and the frequency with which people can change numbers. Location may not be permanent or tethered to a home. For example, migrant workers may cross nation-state boundaries, in some cases on a daily basis. So a way forward that we propose based on some of our research is to consider is to be careful with data and until they're trustworthy and combine data sets with an understanding of context. We call for looking into understanding the vibrant human infrastructures, which points to new ways of looking at data as dialogue rather than as operations. And this leads to new questions on social audits, which is an excellent technique that's used by many civil society groups in India, where communities are involved in auditing the services that are supposedly provided to them by actually having an official or an NGO member read out what was supposed to be disbursed. There are questions around transitive content and around data equity. Categories, ontologies, and behaviors are context-specific and need to be questioned wherever we see them. We also call for doing more with data, moving from doing more with data to doing better with data, rather than feeding into more and more of the hunger around larger and larger data sets. How can we shift that towards more reusability and scientific validity of data? Data collectors and annotators are very crucial members of the data pipeline, and yet we tend to ignore them. And we do not consider raters or data collectors as actually being users of the AI ML systems. Incentives are disproportionate to the work that's involved. And we call for considering not just the ethics and the incentives, but also task design and processes that are used by them. We call for valuing domain expertise, whether it comes from communities that are affected, or from the collectors and the annotators of data, or from scientific or sociological domain experts, and to go beyond the expertise of an machine learning developer. And finally, we call for rethinking incentives in the field of AI and ML, where there's an overemphasis on model development and under recognition of work involved in data. So we invite you to our session at FACT on Monday. It's the final track number 2. So it's the final session, track number 2, where we discuss some of these aspects that I highlighted in a paper called Re-imagining Algorithmic Fairness in India and Beyond. And for data cascades, we have a paper coming up at CHI in May. Thank you so much.